Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
All right, welcome everyone to Matt's session. We are going to be talking about the blockchain in a minute. I will introduce Matt to you right now. Matt is working at Ripple. He is the Director of Developer Relations, and he has experience at IBM and Hewlett Packard, so he's been around at big old companies. So super excited to have him here on board. I remember this morning in the chat that someone was just asking a general question about standing desks, if anyone is using it, if they think they're worth it. Well, I would advise you to look up Matt online, because he has his own website and a blog there. And one of the blogs is about how he built his own standing desk using just stuff you find at IKEA, some cabinets and some countertop. And really interesting to see how he hacked this all together. Like I said, we're going to be talking about the blockchain. Matt's going to explain to us how you can use the tools that Ripple provides to build your own platform on top of their tools. So you can make transactions with intercurrency transactions. So really new stuff for me, and I'm guessing for most of you watching here today. Super excited to see that. So if you have any questions for Matt, be sure to use the chat panel with questions. And Matt, I want to give the stage to you and let us know how to do this stuff.
Great. Thank you very much, Martin. So thank you, everybody, and welcome to my talk here. As described, yes, my name is Matt Hamilton, and I work for Ripple. The standing desk that I'm actually at the moment is not the one I did in the blog post. I have got another one, but yeah, that was a fun project at the start of lockdown to kind of convert a bit of my kitchen that I needed into a workplace. But I've since taken over one of the bedrooms and got a little bit more space here. But anyway, today we're going to talk about developing on the blockchain, building on the blockchain. Now, this is obviously a massively expansive topic. So what I'm going to do first of all is talk a little bit about Ripple, the company that I work for, the XRP ledger, the blockchain that I'm going to be talking about mostly, just to kind of sort of set the scene and slightly, set the boundaries of what we're going to be talking about. Because like I said, this is a massively expansive topic here. So Ripple. So Ripple have about 500 plus employees, 9 global offices, and our vision is to enable value to move around as easily as we can move information today. So, the core thing is that at the moment, right now, I can stream live from the International Space Station video about what's going on there. But if I want to make a payment from, say, here in the UK to Tanzania, for example, that'll still probably take 3 to 5 days and cost me, a number of percent, and I won't know when the transaction gets there until it gets there, right? So we're able to move information around freely at the moment, all across the globe and beyond, yet payments have not caught up. Payments have lagged behind, and that is affecting the businesses that we can do, because a lot of our businesses are based around having to then accommodate the fact that payments are slow and expensive and take time and require trusted parties and all that kind of thing. So that's the kind of the role of Ripple. And just to kind of understand Ripple, because Ripple's a little bit of a complex and misunderstood beast at times. Within Ripple, there's 2 divisions. There's RippleNet, and that's the division that deals with bank-to-bank payments and financial institution payments, kind of similar to many other kind of enterprise software companies. They have some software, they license it to customers. They have a sales team that bring in customers, and that software is used for banks to mainly move around fiat currency, so US dollars, euros, that kind of thing. Then we have RippleX, which is the division I work for, and RippleX is focused on the XRP ledger. Now, the XRP ledger is a open, decentralized, permissionless blockchain that is used for moving value around. And it has a native token, also called XRP, but it also allows you to have other currencies on there as well that I'll cover in a bit. So again, looking at the title of the talk here, and we're talking about kind of building on the blockchain. Well, first of all, let's look at kind of what are we trying to solve. As I said, it's a massive field here, and blockchains have been used, in various levels for all sorts of things. I mean, just for example, the storage of medical history data. People are working on doing that. Music royalty, tracking artists' payments, royalties. If you use one clip of music and another clip of music, or an artist uses a visual from somebody, how do you track which artists get paid for what? Cross-border payments, that's what Ripple are involved in, and that's kind of the area I'm going to focus on in this talk. Personal identity, so verifying who you are. So it might be that you go to a site and they need to verify who you are, and so they need things like passport details and credit card details and proof of address, that kind of thing. And blockchains are being used in that regards as well, to kind of store that sort of information and allow it to be securely moved around. Supply chain. So this is something that IBM were working on a lot, and that's tracking the movement of goods around the world. So tracking the authenticity of things like coffee or olive oil at each stage in the process, from the growers right the way through to the supermarket and in your shopping trolley. And things like gaming. So most games have in-game currencies. They have items that you can buy and sell within games. And people have been using blockchains and cryptocurrencies for looking to kind of expand that world beyond just a game into multiple games and trading and storing that information. So there's a whole lot of things that blockchains can do. The bit that I'm going to focus on, like I said, is moving value, is payments. And this kind of ties into this sort of, why would you look at this? Well, there's kind of 4 key trends here that I'm going to talk about. So one is the tokenization of everything. You might have heard of the term NFT, non-fungible token. That's kind of the kind of hot thing at the moment that a lot of people are looking at. Non-fungible tokens are tokens that are distinct from each other. So you could tokenize a trading card or a collectible or a house or whatever it might be, and that token represents that unique item. You can also have fungible tokens, so you can have things like US dollars, gold, stocks. One US dollar is the same as another US dollar, so you can exchange them. That's what fungible means. And what is growing with this is this notion of sort of tokenizing everything. And the volume of tokenization is looking to, the tokenization market and volume is looking to increase massively over the next few years. And that really brings about a need for some means for interconnecting all of these different systems. And that's one of the things we're looking at with the XRP ledger. And also the payment of those things. If you think about it, if you've tokenized something, then quite often one of the reasons you're doing that is to potentially transfer it to somebody. Well, if you transfer it to somebody, you possibly want something in return. Now, quite often it's a case of you transfer a good for a currency. And so the XRP ledger and kind of payments kind of fits into that bit there. So that's one of the reasons why I'm talking about it. The second trend is the kind of the fragmentation of liquidity in networks. So there's all different cryptocurrencies out there. You've got Bitcoin, Ethereum, XRP, Litecoin, Dogecoin, Binance, etc. And each one of those has people with value on that network. And what we're going to be moving towards is a world in which value can move between different networks. Ripple have been involved in projects like Interledger that allow you to move value from one ledger to another ledger, for example. So just in the same way, it doesn't matter that I'm using, say, Gmail and you're using Hotmail. I can send you an email. I know your email address. I don't have to know what network you're on. And so that's one of the things that's going to sort of grow with sort of interoperability. And this is just the beginning of what's known as DeFi, decentralized finance. Now, the XRP ledger was created in 2011 and was kind of really the first application or sort of notion of decentralized finance. It has within it a decentralized exchange that I'm going to show you in a bit. And that exchange allows people to exchange from one tokenized good to another without needing a trusted third party. So it really does kind of decentralize a lot of the functionality that has typically been held within central entities, things like banks and trading houses. And with that, the rise of what are called DEXs, decentralized exchanges. And so these decentralized exchanges are how you can trade these different assets. Now, the XRP Ledger, like I said, was the first decentralized exchange in 2011. You've now got things like Ethereum came along a few years later, and a few years after that on Ethereum, they built things like Uniswap, and then there's clones of that on various other networks as well, that are kind of an automated market maker. The XRP Ledger has what's called a limit order book decentralized exchange, which is familiar to a lot of people who use centralized exchanges. You have a bid and an offer book, for example. So we'll see that in a bit. So kind of the role we're positioning here is XRP is kind of this universal vehicle of value, right? This idea that, like I said, you can use XRP as a token to interchange between a lot of different other assets. So on the XRP Ledger, you can represent things like dollars, euros, yen, gold, airline miles, reward points, bananas, shoes, whatever you want. And you can use XRP as a kind of an intermediate token for exchanging those things. And this is what I'm going to show you when we kind of dive into the code, an example here. Great thing with the XRP Ledger is it's cheap. So it's, you're talking thousandths of a cent for a transaction, not the sort of $5-6 of Bitcoin and Ethereum, and sometimes, $50, $100. Fast 3-second transactions. So you're not waiting, minutes or hours for transactions to come through. It really is quick. And XRP is traded on a lot of exchanges. So there's a lot of liquidity there. It's accessible from a lot of countries, a lot of currencies, a lot of tools using it. So you're kind of building into a network and able to leverage the kind of network effects of that. I think I've covered most of these things already. Talk about performance, interoperability. It was the original decentralized exchange, liquidity. I've talked about that. The built-in functionality. So this is one of the interesting things with the XRP Ledger is on a lot of blockchains. So blockchains like Ethereum, like I said, that came a few years after the XRP Ledger, has the notion of being a sort of a global computer. And Ethereum was intended to be a very generic system in which you can have smart contracts that you can program in whatever functionality you want. The XRP Ledger has a lot of built-in native functionality that addresses those same needs. So on Ethereum, for example, if you want to issue your own asset, your own token, then you need to use a smart contract. On the XRP Ledger, that's built-in functionality. If you want to run an escrow, that's a smart contract. On a lot of the other blockchains, on the XRP Ledger, it's built in. Things like the decentralized exchange is built in again to the ledger. You don't then have to build on top of that, things like Uniswap on top. So that I've kind of whistled through that fairly quickly. If people have any questions, and I'll answer those at the end. But we are developers. So the idea here now is to kind of dive into that one particular use case I was talking about, payments, that I think underpins so many other parts of blockchain, finance, business, and general development, right? You might be a developer that really, what I'm hoping people watching here is you might be a developer that has never done anything with blockchain or cryptocurrencies before, but you have an application and you would like to add in the functionality to be able to move value around. And hopefully that's what I'm going to be able to show you, how easy it is to do that with the XRP Ledger. So I'm going to jump over to some code. Now, the XRP Ledger, and if I quickly go on here, xrpl.org, and the XRP Ledger, on here is all the documentation, links to references, libraries, for example. So the XRP Ledger is decentralized. It is run entirely separate from Ripple. Ripple do not control it. In fact, actually, in my job, I quite often have to remind some of my colleagues that when they build out new functionality, that they can't just launch that. It has to actually be approved by the rest of the network before it can go live. Ripple don't have the ability to make unilateral changes to the network. But what we do is we produce a series of client libraries. Again, they're all open source libraries, but we have client libraries for Python, for JavaScript, Java, And we've got a straight kind of HTTP and WebSocket APIs if you want to access those directly as well. And so onto some code. I'm more of a Python person, so this is going to be Python code. You can achieve exactly the same thing with JavaScript and Java. I just have a little bit of an itch with too many curly braces, so I much prefer my Python. So what I'm going to do is I'm going to just walk you through some of this code, and I'll show you it in action. So what are we going to do here? I'm going to show you how to make a very simple payment in XRP between two accounts. We've got a bunch of imports in here. I'm not going to necessarily read through them all, but there's a bunch of imports from the XRPL package, which is the Python package PyXRPL, XRPL Py, which you can install with pip. So pip install XRPL Py, and that will give you the XRPL package there. We connect to the testnet. Now there's a couple of different networks. There's the main public network that all of the real value is on. But there's also a test network, and the test network, and there's also a development network as well, DevNet, the third one. But the point with the test network is that anybody can just go on there and create an account, be issued some sort of dummy currency that you can then play around with. So you can develop your application completely using the test net without, having any real world value there necessarily, and then you can transition that over to the main network just by changing the connection string here. So we're connecting to the test network. We instantiate our client here. Now we've got a couple of variables I've got here. We've got a sending wallet and we've got a receiving wallet. Now on the XRP ledger, like a lot of blockchains, addresses or wallets are a public-private key pair. So you have a public key that in the case of the XRP ledger starts with an R generally, and a private key or a secret key that starts with an S. So we need the secret key to our sending wallet, but we need the public key to the receiving wallet. Now, I've put the secret key in here. If anybody were to grab this now, they could go onto the test net and withdraw all my funds from there. But again, this is the test network, so there's no actual real value here. So for the sake of this demonstration, there we go. That's the secret key, and that's the actual corresponding public key as well. And I can go and look at these accounts here. If I go to a site called XRP Toolkit, I can look on here, and let me just double check. Our address here ends FQL, and if I look on here, FQL, and in this account I have 911 XRP. I also have some US dollars in that account as well. I'll get onto that in the next bit of the demo. But for the moment, we've got 911 US dollars. There's a receiving wallet address as well that ends MVQ, and I can go here, and I've got them all loaded up here. So go MVQ, and you see that's got 1,088 XRP there. And if I go back to FQL, there we go. So 911 there. So what we're going to do is we're going to send some amount. So how much are we going to send here? Well, it is 19 minutes past the hour, so I'm going to send 19 XRP. We instantiate our wallet. I just print out here the sending and receiving addresses. And then we need to construct our payment object. And our payment object has an account that we're sending from. And we have the address, what's called the classic address there that we get from the sending wallet. We have an amount, and we're going to send 19 XRP. Now, on the XRP ledger, you've got XRP, and then a millionth of an XRP is called a drop. And a lot of the mechanisms within the XRP ledger, when they are referring to XRP, refer to it as drops. So what we're doing is we're converting XRP to drops with just this little utility method here, which just multiplies it by a million. So that amount there would be 19 million drops, which is 19 XRP. We've got our destination address, and we have a fee. And like I said, that fee there is minuscule. Again, that's in drops. That's 10 drops, which is 10 millionths of an XRP. So that's, we're talking thousandths, tens of a thousandth of a cent, something like that. Very small. We need to sign our transaction, and we have a method here called safe sign and autofill, and that fills in some of the defaults around the network. So there's another method, a similar method that's just sign transaction, and that you have to specify a lot more of the defaults for. But in this one, we're just passing in the transaction payment here that we created, the sending wallet we're sending it from, and the client instance. Once we've signed it, we've got to send it. So here we go. And again, we're calling this send reliable submission. And the reason we call that send reliable submission method is when you send a transaction to the XRP ledger, it gets broadcast to the network. It gets included in the next ledger or next block on the network. And the block time is about 3 or 4 seconds. So about every 3 or 4 seconds, a new block will come along. This is put in the block. And then this send reliable submission will actually check that it has been included, accepted by the network in the next ledger that goes past. So it'll actually confirm it. So this is actually a blocking request, and it will take a couple of seconds, but it'll actually do that for you. You can do it asynchronously as well. There's an asynchronous version of this. And if you're using Node.js and the JavaScript library, you would do that asynchronously and then have a promise or an async method, and you poll and check that that's been submitted reliably. And then we print out the transaction hash. Now, like I said, there's about 3 or 4 seconds per block time. So this demo, I can actually show you right now live. If this was, for example, a Bitcoin transaction, I couldn't really show you that because it takes 10 minutes to appear and potentially in the next block, and that's a variable amount. It's on average 10 minutes, but it might be, we're waiting for 20 minutes for that to turn up. And you then have to wait a certain number of block times for what's called probabilistic finality. So with the way that proof of work networks like Bitcoin work, you have to, I'm shortening the details here, but wait a certain amount of time to ensure a certain number of other blocks have gone past to be confident that your transaction is final and won't be overwritten by another transaction. So with Bitcoin, generally it's accepted to wait about an hour for a reasonable sized transaction. Whereas on the XRP ledger, like I said, it's about 3 or 4 seconds. So if I make this payment here and do this, then it's going through and I can actually switch over. You can see it just in the background here. But if I switch over, you'll see this. There we go. It's dropped down 823. And that transaction has gone through. And if I switch over to our receiving one, which was at MVQ, I think, it's come through. And it says 88. And the reason it says 88 is because I probably didn't save the file here. No, I didn't save my transaction. Let me do that again. I'll save that transaction, just so you know that it's not. We'll see here. You'll see this 88. You'll see a transaction come up 19. There we go. So we've just made a payment there from one wallet to another wallet in, like I said, literally a few seconds there. Completely decentralized. There's no central authority here. This is all just going over a blockchain that is secured by a whole number of machines, basically verifying these transactions around the world. You can actually see that on, you can see the transactions go past here on this Explorer. So this is the block Explorer, and you can see the transactions go past on each block. You'll see, so 25 transactions, 39 transactions, 26 transactions. And if I switch over to testnet, you'll see there'll probably be a lot less data coming through here, a lot fewer transactions. But we should see, if I make this payment again, we should see our payment come through, and it should show up here. And it'll be in one of these blocks here. There we go. It's that blue one there. No, sorry, it's the green one. That's the green one. Blue one's an offer create on there that's on the decentralized exchange. But you can actually see these transactions go through. So that's great. It's making a XRP transaction there. Where this gets really interesting is when we look at cross-currency transactions. Now, this is a similar script that I've written. It's a little bit more complex, so I'll walk through it, but I'll try and go reasonably quickly. But the point of what I'm doing here is I'm actually going to make a payment from US dollars and have it turn up in Bitcoin on the receiving end. So if we look at our wallets here, this receiving wallet has got actually 0.0014 Bitcoin, and our sending wallet has $9,950 US. So I'm going to make a payment, and I'm going to say, send some Bitcoin to the destination, but funds that transaction using US dollars. And what will happen is the ledger, when it sends the payment, will look on the decentralized exchange built into the network. And the decentralized exchange has a number of orders on, so it looks a little bit like this. This is actually the live order book that I'm looking at here. The testnet order book looks a little more barren than this because there's not so much activity going on. But you have bids and offers here on the network for what people are willing to pay. And so what will happen is the network will actually look at the decentralized exchange and go, I've got US dollars. Who will buy my US dollars and sell me some Bitcoin? Now, the really clever bit is that it does pathfinding. And what it'll actually do is it'll look at the network and go, okay, if we haven't got the ability to go US dollars to Bitcoin, can I go US dollars to XRP and then XRP to Bitcoin? And it will do this pathfinding kind of multi-hop, all as a single atomic transaction. Now, you can imagine, in a wider world, this might go from US dollars to shoes to oil to bananas to strawberries to Bitcoin or whatever, right? It depends entirely upon what people have on the XRP ledger. And the pathfinding algorithm will look for the cheapest route. So I'll look and see where the most liquidity is and work out the cheapest route. So back to our code. Same thing again, we're connecting to the testnet. We have a sending wallet, we have the receiving address, but we're defining the sending currency and we're sending US dollars. We have this, what's called an issuer. And on the XRP ledger, you can have multiple issuers. So you can have multiple issuers of US dollars on the XRP ledger. In the same way that, for example, you have, if you're familiar with other cryptocurrencies, you have Tether offering US dollars. You have Circle offering US dollars. You have USDT, USDC. You have BUSD, which is Binance's dollars. So you have multiple issuers that issue effectively a tokenized version of US dollars on the blockchain. In this case, this is the issuer, and it's just denoted with a address. You can actually, there is like an address book that you can make that look a bit nicer, a bit like a sort of reverse DNS lookup, and give that a nicer name. But in this demo, I'm just using the raw name here. So we're sending US dollars, and we want Bitcoin. The amount we're going to send is we're going to send 0.005 Bitcoin. And I'm going to use a maximum of $1,000 to fund that because I don't know exactly how many dollars are going to be used. Now, I can go either way. I can either say, send this certain amount of, use a certain amount of dollars and get as much Bitcoin as you can, or I can say, give me this exact amount of Bitcoin and use as many dollars as you want to do that. We print out the sending and receiving address. Now, we do this path find. So first of all, we ask the server to find the paths to get from US dollars to Bitcoin. We take that path and we're actually just going to grab the first path that's created, the 0th path that's created, and we construct our payment. Similar as before, but we have this send max field in here. And the amount, rather than just being a amount in drops, it's actually this issued currency amount instance because we have an amount and we have that is the currency code and the issuer. We've got a destination, a fee, we sign the transaction exactly the same as we did before, and we send the transaction. So let's run this. And if I go here and run it again, run currency, you'll see here it's actually found paths here. So it's found a currency to go from Bitcoin. And if we go back, if we're quick enough, we might even see it go through. Oh, we see it there, sent Bitcoin. So 0.005 Bitcoin went out, but we were funded with US dollars. So our US dollar value went down slightly. Now, it might have been quite quick to spot here. So let's see if we can do this again and make it a slightly larger amount. I can't remember how much I've got in the exchange here to make this work, but let's take a 0 off of there. And if I again here and go back to our browser, we should see this US dollar amount here. Yep, you see it just dropped down, and the US dollar amount dropped down as we sent some Bitcoin. And we'll see on the receiver side, we will see here MVQ, we will see it's received some Bitcoin here, 0.005 Bitcoin. And if we look at that transaction, what we can see is we can see the transaction here. So we say, using at most $1,000, send 0.005 Bitcoin to that destination. And if we look at the detail view, you can see what happened here. The transaction was successful, tells you the ledger number it was validated in, tells you the sequence number of the transaction, tells you where the source and destination. It says it was instructed to deliver 0.005 Bitcoin by spending up to $1,000. The actual amount delivered was 0.005 Bitcoin. Now, it might be that you've asked to send too much and you don't have enough to cover the costs. So you can tell the network, I'm okay with you delivering slightly less than I've asked for. And you can see the transaction cost, virtually nothing there. And you can see what actually happened here. There's a whole load of modified nodes on the network, but you can see that an offer on the network, so there was a XRP BTC offer, and that was partially filled. And you should be able to see an XRP USD offer. The XRP USD offer was filled, and that's gone through kind of as well. And that's gone through, used up all of that offer, and has been deleted then from the order books. So that's that transaction gone through. So we used US dollars to send to Bitcoin using the XRP ledger in a decentralized way. And XRP was used as kind of an intermediate bridge currency between those two. Like I said, you could represent any currency on there, and you could then transact between them. So I think that's it for my demo. Again, kind of the whole point of what we're trying to do with this is to allow payment to move as easily as information. And what that allows is greater inclusion and fairness in the financial system, right? Those people that are often least able to afford to pay for financial services or cross-currency, cross-border payments are those that are most affected by it. And so what we're trying to do at Ripple is reduce the cost of cross-border payments to make it, a more equitable and fairer world for people. So thank you very much, and I'll happily answer any questions.
Then you probably need me back, Matt. Thanks a lot for sharing this. I have to say that it was really cool to see how you could, it seemed really easy, even though I don't speak Python, to make some transactions. So that speaks to your skills as a speaker.
Well, job done then. That's good. That's good to hear. So thank you.
All right, we're going to jump into the audience questions. And as a reminder to the audience, if you have any questions, you can still type them. We have some time left for your questions. First question is from Tony. He says, I'm a developer, tried smart contracts for a bit, but I'm still a beginner. If I wanted to work full-time on blockchains and DeFi, what are your recommendations on where to start?
So you were talking about smart contracts and talking about DeFi, and a lot of DeFi, like you say, is handled via smart contracts. Now, the most dominant language for smart contracts is called Solidity, that is used on Ethereum and a lot of other networks that use the Ethereum virtual machine. So there's a new network coming up at the moment called Flare. There's some forks of Ethereum as well that use the Ethereum virtual machine, things like Binance Smart Chain. So in terms of if you're wanting to get into creating smart contracts, then probably your best bet is looking at something like Solidity for that. There's a number of other approaches as well. So the XRP ledger is, there's something called Hooks that is currently in development at the moment. But Hooks is a smart contract functionality for the XRP ledger. And actually those contracts are written in C and compiled down to WebAssembly and then executed in a WebAssembly virtual machine on the network.
Cool. Tony, so now you know where to go. Another great question from Tony. Tony gets a lot of upvotes on his questions. What differs smart contract programming on XRP from Ethereum or Solidity, for example?
Sorry, say the question again.
So what differs smart contract programming on XRP from Ethereum / Solidarity, for example?
Okay, so the difference being is that the XRP ledger doesn't have, at the moment, native smart contract functionality built in. So it doesn't have an equivalent of Solidity. So there's a thing called Hooks that is coming towards the end of the year that will allow that kind of thing. Back in the early days of the XRP ledger, there was a big kind of discussion about whether, when the whole concept of smart contracts was being created, whether smart contracts should run on-chain or off-chain. And the creator of Ethereum, Vitalik Buterin, actually was trying to intern at Ripple at the time before he created Ethereum. And him and Stefan Thomas, the CTO of Ripple, used to have apparently a lot of discussions about where, the concept of smart contracts before smart contracts even really existed. And Ripple took the approach of going off-chain, and they had a product called Codius, a project called Codius, which is now mainly being run by the Interledger Foundation. And Ethereum was created and had a smart contract language on-chain called Solidity. Now, there's pros and cons to both. And one of the pros of having smart contracts in the chain with Ethereum is that they're right there to use. The disadvantage being is they have limited capabilities in interacting with the outside world. So with Codius, for example, you can run kind of any code in any language, and it's a bit like, it's not quite a smart contract in the same way Solidity is. It's more like, think about like Kubernetes with self-payment or Docker with self-payment, right? It's the ability to run some code that can basically pay for its own execution on some infrastructure. So that's the kind of differences between the two.
Awesome. So Tony, once again, great question. Thank you. Next question is from, I hope I pronounce this right, Gao Feng Jin. What is the vision for Ripple in the next 10 years? And if I remember correctly, Ripple is now 10 years old. So
yeah,
double the years.
Yeah, exactly. So double the years. Wow. Well, think about how far we've come in 10 years. Trying to predict another 10 years in the future is a pretty big ask.
Aim for the moon.
Aim for the moon. Aim for the moon. Well, exactly. So like I said, the big thing is being able to move payment around as easily as we can move value. And this is still something we're working on. And there's a lot of parts to this. The technical part, I think we've kind of got solved. But then you've got the whole issue of the regulatory environment. As you probably know at the moment, if you sell a cryptocurrency in many jurisdictions, that's a taxable event, and you've got to record it as a taxable event. Well, you don't want to pay for a taxable event when you go and buy yourself a coffee, right? So there's a lot of the rest of financial world and regulatory world that's got to catch up. But once that happens, it's going to be the case of this transparent payments that are happening behind the scenes. So you turn up with your laptop at an airport, and when you open it up and you go to connect to the airport Wi-Fi, it comes up and it says, right, well, we're going to charge you €5 for 30 minutes access. Register here, put in your username, put in your email address, your password, your inside leg measurement, right? They ask for all these details just to give you Wi-Fi, right? Well, imagine a world in which you open your laptop sees the Wi-Fi and goes, hey, Wi-Fi, how much? And Wi-Fi goes, well, it's 0.001 XRP per second or whatever. And your laptop goes, okay, that's fine. I'm authorized to spend that. And your laptop then basically pays literally per second or per byte even for the data that's coming down. And so suddenly you've got a whole different mechanism there, because you don't need to know what the username is. You don't need a password because you don't need an account. And the reason you don't need an account is because you don't need to supply a credit card, and you don't need to supply your address details to verify the credit card, because you've just paid. You've just sent the actual payment and it has arrived and been accepted. So there's nothing to backtrack on, right? So that means that with that thing, you can remove a whole load of the privacy aspect or privacy problems around taking payments online and the friction around payments online. So the future, I think, is just a lot more payments, a lot easier, and things paying other things, right? So not just you explicitly paying, but your phone paying on behalf of your laptop to the Wi-Fi system to do this, to do that, and payments going on transparently in the background.
This sounds amazing. Sometimes, like, I have an Apple Watch, and even paying with that feels like black magic still. I have it for 3 years, and still feels like black magic. But having your laptop just set the limit, like, for Wi-Fi, I'm fine with you paying X amount.
Yeah.
This sounds really cool. So please make it happen.
We're working on it. I think it's going to be a very different world, and it enables a whole lot of business models that just are not possible right now.
Yeah. Well, what are you doing here? Get back to coding, Matt.
Yeah, exactly.
All right. Next question is from Timo. What's the course prediction for XRP specifically over the next 1 to 2 years?
I think he's talking about the price then from that point of view as to what the price of XRP is going to be, right?
What's your course prediction, he says. So
course prediction.
So the course of XRP, yeah.
The course of XRP. So I think he's talking about the price there. And I'm not going to give any price predictions because they're always wrong, right? It's going to go up, down, or sideways. Who knows? And ultimately, if this adoption that I'm talking about happens, then the value of things are going to go up. That's kind of the natural way. The key is getting the adoption, is building things on top, and a lot of that, like I said, at the moment is hampered not by the technological side, but by the regulatory side, and by the kind of legacy financial system side. Certain processes are built in certain ways because payments are slow and expensive, right? So if it's going to cost you $100 to make a payment, then you're going to want to do batches of $10,000 or $100,000, right? So you're not paying so much. So by virtue of you're going to be doing payments of $100,000, you're going to be wanting to ship $100,000 worth of goods at a time. But what happens when payments cost virtually nothing, and you can send one item at a time because there's no overhead to the payment? It changes a lot of the dynamics of like supply chains worldwide, not just finance.
All right, cool. Another question is from Alexander, and Alexander asks, can the XRP ledger be used to build a local application, for example, running on a robot that is paid per use? And if so, how?
Oh, wow, interesting. So I do know somebody who has created, if you go Google something like XRP ledger or XRP drinks machine, you'll find a guy called Barath who created a drinks dispenser connected to the XRP ledger. And basically you can make a payment and it'll dispense you beer or whatever, right? So it's already starting to be used in kind of embedded type systems. So yes, you could use it on a robot, and that robot could accept payment and only move when it's been paid to move or whatever that might be. So yeah, that's certainly possible.
That sounds like you could open a bar with like 10 of those robots and order a martini at robot 6 and...
You've not been listening, have you? You're not going to order the martini. Your laptop's going to order the martini, right? Your laptop's going to look at your code and go, wait a minute here, you need another drink. And your laptop's going to, after running the linter on your code, is going to order the drink on your behalf for the robot to deliver and have paid for it for you.
Yeah, this code is rubbish. You need a martini.
Yeah, exactly. So that's how it's going to work in the future.
I'm ready for this.
Sounds good.
So we have time for one more question. Quick answer. Are Ripple working on the Internet of Things, like machine paying each other? Well, can you touch on this?
Yes, they are. So, yep, we've been working on that. That's kind of what all of this is going to be working towards. Is the Internet of Things and the Internet of Value, right? Once you've got the Internet of Things and you've got the Internet of Value together, then things can be paying each other. So, yeah,
that's amazing. All right, that is all the time that we have. There are some questions left in the chat. So, Matt, if you could stay in the session and answer them on the chat, that would be lovely.
Sure.
And otherwise, people can contact you on the platform, of course, on the StreamYard platform. Yeah. Matt, thanks a lot. It's been a pleasure having you. I hope to see you again soon. Bye-bye.
Great. Thanks a lot.
you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.